video, I'm going to explain empirical formulas to you and actually show you how to find one. So first of all, let's get down the definition of empirical formula. It is the simplest whole number ratio of atoms in a compound. So we're going to look at subscripts, for example, a 4 and a 10 in this first compound. Is that the simplest ratio? Carbon to hydrogen, it's 4 to 10. Can we reduce that ratio by something? We can reduce those numbers both by 2. And so if we divide both by 2, we'd get C2H5. This is the empirical formula for this compound. Okay, now the next one, NH3. Can we reduce the 1 and the 3 by some factor? We can't. The empirical formula, that is the empirical formula, NH3. It's as simple as it gets. 1 nitrogen, 3 hydrogens. The last one, I see a factor of 6 there. Could we reduce that by 6? CH2O1. Okay, so those are molecular formulas, and then we have reduced them down to the empirical formula. Now, empirical formulas, how do we get those? Like, how do we know what a compound is? And the way we know the formula for a compound, the way we get these types of formulas for a compound is by mass data. And so let's say we had a sample of some compound, and I'm going to try to find what these numbers are. It's C, I'm going to put a little question mark, H question mark, N question mark. I mean, how do we know? I know that 3 elements make up this compound. So by chemical analysis, we can determine the mass percent of each element present. Now, let's take these numbers. Let's first assume that we have 100 grams of compound. Okay, so I've got 100 grams of my compound. And I did that 100 grams just to make the math easy. So what's 62% of 100? Well, let's just use our percentages as grams. And then 24 grams of nitrogen. Okay, so the first step is just get your masses. Now, the next step, I want to convert each of these to moles. So we know how to do that now. We're going to use the molar mass of carbon. We're just going to pick off those molar masses from the periodic table. And hydrogen is 1.01. Okay, now I have to tell you, right now you're going to your periodic table a lot. And I know right now it's hard to even find elements. The more you use it, the quicker you'll get. You'll find elements, and then here's the crazy thing. You're going to actually, if you do this long enough, you'll memorize some of these molar masses. It'll just happen. You don't have to memorize them, of course, but it just will happen. All right, so we get moles of each of these. Okay, remember when we multiply, those grams will cancel, and we get moles of each element present. Okay, so that is 5.17. Now, when you do this step, don't drop your sig figs here. Okay, moles of carbon, moles of hydrogen, and then 1.72 moles of nitrogen. I started with 3 sig figs. I want 3 sig figs in my moles. Okay, now, can I use those decimal numbers as subscripts in my compound? Because I really want to take these numbers, they go right there. Well, I can't. You've never seen decimal numbers. I can't do that. I've got to get these to whole numbers. So this is my favorite part. What we're going to do to get to whole numbers is divide by the smallest. So I've got 3 different numbers here, and this is the smallest, the 1.72. So divide each of your numbers by 1.72. So we divide by the smallest. Okay, and what are we going to get? I hope we get whole numbers. Well, this one obviously is a 1. This one's an 8, and this one is a 3. And guess what those whole numbers are? Those are the subscripts for the formula. So here's my answer. The empirical formula is, don't just circle those numbers, it is C3H8N1. That is your empirical formula. Okay, so I hope this helps you do empirical formulas. It's a couple calculations. It may be a little bit tedious, but with some practice, you'll be able to do it really well. Now, let's move ahead to molecular formulas. What is a molecular formula? That is the actual formula. Where did it come from? It's some multiple of the empirical formula. So I've got 3 compounds here. Let's just take a look at these 3. C4H8, C3H6, and C6H12. These are all real molecular formulas, and they all have the same empirical formula, which is CH2. Guess what? CH2 doesn't exist. You know why? It's not stable. Doesn't exist. These formulas are true, real molecular formulas that do exist. But if you broke them down to empirical formula, you would get CH2 for all 3. So I want to do another question for you and just let you think about the difference in empirical and molecular formulas. So let's look at this question. The empirical formula of a compound is CH2. It's got a molar mass of 56. What is the molecular formula? Well, I know it's going to be some multiple of that number, right? So let's first find the molar mass of CH2. Well, 1 carbon is 12 grams, and then 2 hydrogens, each one is 1.01, is going to give me, let's see what that is, 14.03 grams. Okay, so well, I'm looking for a molar mass of 56, and CH2 is 14.03. So it's definitely not CH2. So what multiple of 14 is 56? Well, 56 divided by 14.03 is exactly 4. So what I want to do is multiply that empirical formula by 4. So here's my answer. C4H8. That is a molecular formula that has that molar mass, and it also has an empirical formula of CH2. So there's a difference in empirical formula and molecular formula. I hope this helps. You can do chemistry.